Hey guys, Vasily here from cnvrg. I'm an AI architect with cnvrg, and in this video I'll be walking you through creating flows and pipelines for your end-to-end AI and machine learning workflows. So to get started, you can just watch along as I show you here in the demo, or you can open up one of your projects and head over to the flows section. Here you can easily create new flows. And inside of a new flow, you'll just have a blank canvas. That blank canvas is ready for you to customize with your own particular title, as well as to start adding tasks to the canvas. Now, if you haven't already exposed yourself to the AI library, we do have an AI library, and there's a separate video that kind of highlights what that is and how you can use it. So definitely recommend watching that. If you already know what it is, great. This is where it comes in. Here you can actually select from components in the AI library to serve as the template for your task. And so there's a lot of commonly used algorithms and machine learning models that you can choose from that you can then train and pass your own parameter overrides for your specific data. So in this case, if you select a model, it'll be added to the screen. And this is where you can now select your actual data as well as various other overrides that you want to provide. For each task in cnvrg, you have the ability now to set things like conditions. So if you have a particular tag inside of the model that's running that you want to then compare to a specific value and make sure that it's above or below a certain threshold, you can actually do that here. And you can do that for any particular task on the canvas, any particular tag within that task. You can also, for more complicated matters, enable human-in-the-loop validation. That allows you to select from a user that's added as a collaborator to the project or the environment itself, and they will be notified when that task completes so that they can come verify and ensure the accuracy of that particular component. Now, each task on the canvas can also have its own compute and its own image assigned to it. Now, this is particularly useful, especially when dealing with multiple models being trained in the same flow, some being run on a particular type of GPU architecture, while others might just be run on optimized CPUs. It also is very useful if you're dealing with hybrid or multi-cloud environments where you might want to deploy the task in the experiment itself and co-locate it either with the data, where the data lives, or ensure that it's actually being trained where the budget and the resources allocated. So you can have simultaneously two models being trained, one in AWS, one in Azure, one on-premise. It really doesn't matter. cnvrg supports all of that from a single cnvrg instance. And so you can select the proper template that will point to the right environment. And in this case, if you want to train with a GPU, just select that GPU hardware and how many resources you're going to require. And then also, since we're going to be doing, say, GPU, we might want to then ensure that we have the GPU image so that all of the software is pre-configured for us. And now for tasks, as well as the entire flow itself, you're not creating anything proprietary or special here. It's dynamically creating a YAML file, which you can treat as code, you can templatize, and you can also use this to execute from a CLI and add to an automation. Now, once you've configured everything for a particular task, you can leave it on the canvas, and you can choose to save a particular version of your flow. You can also now add things like data tasks. So for this MNIST example that we're going through, we can now select the MNIST dataset as well as a particular version of that dataset if we should choose to do so, or just go with the latest. I'm going to go ahead and go with the latest. So I've added my MNIST dataset here. Now, we don't need a decision tree, so I'll go ahead and remove that. And since we've created our own model that we're training in and running experiments on, we can go ahead and use a custom task. Since it's not already available in the AI library, we can now specify it ourselves. So in this case, it was a Python file, so we're executing Python. and that's on the cnn.py file. Now, we've created a custom task, so this is our CNN training file. So I'll go ahead and title it accordingly. And this is where I can now provide key value overrides for things like batch size or anything else that I want to override at this point. And I can also choose to enable hyperparameter optimization, or I can just do a single run on the overrides and parameters that I currently have set. Again, this is where you could set your conditions or human in the loop validation. And this is where I can also now select what I'm going to run my experiment on. So when we did the experiment video, we selected GPU and the NVIDIA converged GPU image. So we'll select that here as well. And if this is something that you want to have reusable across other projects and for other team members, and you want to make that easy for them, you can choose to publish it as a library component. And now CNN train will be available for us in the dropdown for future usage. Now that we have our training file loaded as a task on the canvas, we can connect it to our data set. And now it will kick off as soon as the data set is loaded. It'll all execute from left to right here. It's important to note as well that it's not all in series. You can definitely run multiple tasks in parallel. So if I wanted to run multiple experiments, say I wanted to also run my CNN auto ML file side by side to see which one was better, I could just add another component on the canvas for that, configure GPUs on that as well, select the proper image, and save those changes. And now I have gone from training 1 model to training 2. Now, at the end of model training, these models will automatically, based on their code, say create a model file, a weights file, whatever that might be. And you can choose to do whatever you like after that. These don't have to be training events. They can be data preparation tasks. You can pre-process data with these tasks. You can really enable any type of end-to-end flow. And because Converge is a code-first platform, you can write custom scripts and have those executed by tasks on the canvas here. And you can also choose to have a deployment task. So once everything has been trained, you can choose to now connect it to an already existing deployment or create a new endpoint. If I create a new endpoint, I can select what type of endpoint I want to create and provide any parameters for that endpoint here, and that will be created for me automatically, as well as updated automatically every time the flow executes down the line. You can choose from TensorFlow serving, batch, web service, and stream. Here I'll just go with web service. If you want to know more about the actual inferencing and endpoint serving, watch the video on that. We go into more detail there. For this particular scenario, we'll just take some of the defaults. And in order to deploy, as you'll see in the deployment video, you'd simply need to provide the file that does the prediction and has the inferencing logic built into it, as well as simply a function inside of that file that will handle the input and then return a result. And that result can be anything that you want. You can also specify a pre-processing script file and function if you need that data to be processed before passing it to the inferencing layer. And this is where you can also select the language, pass custom configurations, or in the case of MNIST, since we're going to be accepting a file as input, we're getting image files for this use case, we can enable that, and what will then happen is that we'll have a file passed to our predict function, and then that will then generate the response after inference. You can now choose to set conditions here as well as human in the loop validation, save that off, and connect your models to it. And in those conditions, you can specify what you want to compare between these two models so that you can always deploy the right one. You can go ahead and then save that off. You see everything we've done has created a version here, so you always have that retraceability and you can always roll back. You can grab the YAML for this full flow and templatize that out. You can enable continual learning, so every time the MNIST dataset updates, I can select MNIST dataset and on dataset update. It will trigger this flow to run automatically. You can also enable webhook execution so that an API call to this particular URL will automatically trigger this flow. Or you can choose to just execute it manually or on a scheduled recurring basis. So you have all those options to choose from. If you go ahead and click run or execute it through the CLI, we see here the flow is, it jumps us into the experiments panel. We see the MNIST dataset has already finished loading and now the training has kicked off. So that has initialized 2 experiments for us, 1 for each task. And we have the deployment task still pending. Now, this won't initialize until these are complete. And so that always makes sure that you're only utilizing and allocating resources when needed. So here we see that it's initializing on the compute that we selected, and it's already initialized those tags for us that it sees it's going to be collecting down the line. And then these will then go ahead and run and can be compared here through the UI or through a TensorBoard session. Now, jumping over into experiments, and if you've watched the experiments video, you can see a lot more detail about actually managing and monitoring your experiments. Once these finish initializing and executing, you can then always track the successfully completed experiments in the experiments panel, and you can see all of the various metrics that you logged out. And each task that you put on the flow will run as its own experiment, so you can always go back and look at those experiments as they relate to the flows, and you can always then make changes to those flows and rerun and show any experiments from the flows page. That way you can always see what experiments were run by what flow very easily, and the DAG is provided so that you can always also understand the logic of how they executed. So that was the brief end-to-end demonstration of flows. I hope you enjoyed it. Thank you for watching.